Right, let's look at the answers to the simultaneous equations exercises. Let's quickly just remember the step. There's different ways to do it, but step number 1, you isolate one letter. So you get either x is equal to something or y is equal to something. Step number 2, substitute this into the other equation. Then you will have an equation with one unknown in it, so you can solve for the letter in that equation. And then finally you can substitute back into any equation, any of the three equations which you then have in order to find the other letter. Well, let's just check what this means, because that's all great, but what does it mean? Okay, now step number 1, I pick an easy equation and isolate a letter. Now if I look at these two, both of them are relatively easy, and both of them have already got one of the letters isolated. So step 1 is kind of done for you here. Step 2 was to take one of these equations and substitute it into the other equation. So for example, I'm going to substitute, instead of having y is equal to negative 3x minus 7, I'm going to substitute y for 2x plus 3, because that's what y was equal to. Which means I've done step 1, isolate a letter, done for me. Substitute this into the other equation. Now I need to solve for x. So I plus 3x to both sides. So I get 5x plus 3 is negative 7. Then I minus 3 from both sides. So I get 5x is negative 10. And then I divide by 5. So I get x is negative 2. And my last step was to take this solution and substitute it back into either of these equations. Will give you the same answer. So I'm going to substitute it back into y is equal to 2x plus 3. So I know y is equal to 2 times negative 2 plus 3. So therefore, y is equal to negative 4 plus 3. So y is equal to negative 1. So x is equal to negative 2, y is equal to negative 1. Now, there is a different way to do this, so I'm going to show you the other method. The other method is very simple. If you have the same thing in both equations, why can't you just add the equations together? Or in fact, why can't you just subtract the entire equation? Now, you're allowed to do this because technically I'm subtracting the same thing from both sides, because y and negative 3x minus 7 are equal. So this only works because I have y minus y is nothing. So they eliminate themselves from the equation. Now I have 2x minus minus 2x. Now minus minus is a plus, so I actually get 5x, and I get 3 minus minus 7, which is actually plus 7, so I get plus 10, which means I can minus 10 on both sides and get exactly what I got there and solve for x. So in this equation, in this example, it worked, but it only worked because I had a y in both equations. Let's look at the next example. 4x minus 3y minus 10 equals 0, and 4x equals 2 minus y. Now here, do I have the same thing in both equations? I do. So I could subtract these two equations and get rid of that 4x entirely. Or I can use step 1, 2, 3, 4, which was pick the easiest equation. This one looks relatively easy because there's a y all by itself there. So I'm going to pick 4x equals 2 minus y, and I'm going to make that equation number 1. Now I'm going to rearrange it to make y the subject of the formula. So I'm going to minus 2 on both sides, but I want y as the subject of the formula, so I'm going to divide by negative 1 throughout the equation until I get equation number 3. So this guy was equation number 2, and now I'm going to substitute equation number 3 into equation number 2. So therefore I have 4x minus 3y, but y is the same as minus 4x plus 2 minus 10 equals 0. Now that's an easy simple linear equation with one letter. So 4x plus 12x minus 6 minus 10 equals 0. To collect up like terms, I have 16x minus 16 equals 0. Add 16 to both sides, divide by 16 on both sides, and I get x is equal to 1. Now this x is equal to 1 can go into any of these equations. You can put it in there, you can put it in there, Or probably the easiest thing to do would be to put this x is equal to 1 into this equation, because it already has y as the subject. So that's what I would do. I would go back to the fact that y is equal to minus 4x plus 2 from equation number 3. So that means if x is 1, it's minus 4 plus 2. So y is equal to minus 2. Now, the nice thing about simultaneous equations, as with all equations, you can always go substitute those two in and check that it works in both your equations. Now, I could have done the subtract the two equations here. So if you prefer that method, I'll let you try that one, and you should get exactly the same answer. Right, the last one, neither of these two equations looks particularly nice. This one has 3x and 6x. So if I'm going to isolate one of the letters, I'm going to have to divide. But this one does too. So if we're doing the first method here, either one of these is going to land us up with fractions. So, oh well, pick one of them. I'm going to pick this guy, because at least if I divide by 3, my 6 can be divided by 3. Now, my 11 doesn't exactly divide by 3, but it's fine. I'm going to have to use fractions. So equation number 1 and equation number 2. From equation number 1, I'm going to start rearranging, and I'm going to isolate x. So I minus 6y on both sides, and then I divide by 3. So I get minus 2y, and I get 11 over 3. But so what? And this is equation number 3. I'm now going to go and place this into equation number 2. So therefore, oh, now my pen doesn't work. Right, I've fixed my pen, so let's carry on. So I'm going to place my x into my 2x is equal to 3x plus 5. So I was saying that I'm going to do 2, and instead of x, I'm going to replace it with minus 2y plus 11 over 3 equals 3y plus 5. So all I've gone and done there is brought all of these things down and replaced my x. Now this is great, because now I have an equation with one unknown. So I'm going to multiply out minus 4y. Well, this doesn't simplify nicely, but 22 over 3. Use your calculator if you don't like fractions. Equals 3y plus 5. Now, guys, I can clearly see I'm heading for some fractions. So there's nothing wrong with using your calculator and just making sure that you don't make any mistakes. Now, I'm going to minus 3y on both sides to get minus 7y plus 22 over 3 is equal to 0 plus 5. So I'm just going to write 5. Now I'm going to minus 22 over 3 on both sides, and I'm going to use my calculator. 5 minus 22 over 3. And my calculator tells me it's negative 7 over 3. And then I'm going to divide by negative 7 on both sides. And again, you may use your calculator, but I get y is equal to a third. Now finally, I can go and take this y value, and I always go put it back into equation 3, because I have x isolated. So x would be negative 2 times a third plus 11 over 3. And again, you're welcome to just pick up a calculator. This is negative 2 thirds plus 11 over 3, which I think is going to give me 9 over 3, which will give me 3. But check on your calculator, and it does indeed give me 3. So I have my two answers. Now, just for those of us who like to use the elimination, I thought I'd show you how this question could use the elimination. So I'm just going to erase all my working out for this method. So those of us who like to add our equations together to eliminate things, this one doesn't work perfectly, because none of these, if I have 2x here and I have 3x here, I can't automatically subtract them and get rid of my x's. And if I look at my y's, oh, my pen stops working again. Sorry, I got my pen working again. And if I look at my y's, 3y and 6y also can't automatically, cancel each other out. But I do know that it's perfectly okay to multiply an entire equation by the same thing. And if I multiply this by 2, I could get 6y. And then perhaps I could cancel them. So there's nothing wrong with multiplying that entire equation by 2. So this equation would be exactly the same thing as 4x is 6y plus 10. That's exactly the same thing. Now perhaps I could try and cancel with 3x plus 6y equals 11. Now perhaps I could subtract or add these equations together and get rid of my y's. Now, it might be better for me to minus 6y on both sides so that I have my y's on the same side. And now if I write them under each other, I can immediately, oh, my pen goes again. Sorry, my pen keeps losing connection. Anyway, let's pick up where we left off. If I did take the 6y and I minused it on both sides, I now have a perfect, I could add these equations together and I get 7x and 22, which means I can solve for x immediately just by simply adding my equations together. So I get x is equal to 22 over 7. And then I can continue finding my y, which is a third. Now, the only problem is I did that wrong, didn't I? Because I can clearly see the 22 over 7 was not what I got earlier, so I added incorrectly. 21 over 7, which would give me my x is equal to 3, which would give me my y is equal to a third. I could go back and put my x is equal to 3 in any one of these equations and solve for y. So that would have been a neat way to do this equation.